Hello, my dear students and the rest of the learners. Welcome to part 18 of a 29-part series of tutorials in Fundamentals of Structured Programming using C. In this presentation, we are going to look at the variable scope, the parameters, and the parameter passing. My name is Memedi M, or you can simply call me Emily Swap. Due to the fact that a function is an entity that is separate from the main program, the variables used and the functions, or by the functions, can be supplied using either global variables or through parameters. A variable scope is therefore the region in the program from where it can be referenced, which starts from the section it's declared. The two main types of scope are the local and the global scopes. When we speak about local variables, the local variables have what we call the local scope, while the global variables have what we call the global scope. So, what are local variables and what is local scope? The local variables are those variables that are declared inside a function and are assigned to be local to that function and therefore are assigned to have what we call a local scope. The content for such variables can only be accessed and are only known by the function in which they are referenced. Therefore, if one wants a value in them to be used by another function, that value must be passed to that other function as a parameter. My dear students and the rest of the learners, it is important for you to know that if you are going to make use of what we call the global variables, then there is no need and there will be no use of parameter passing. But once you make variables to be local, which is a very good security measure in programming, then you must remember that another function cannot be able to access the members of another function unless if that value or that data from one function is passed to the other as a parameter. A parameter is the data or information that is passed either from or to a function during execution. The two types of parameters in a program are the actual parameters and the formal parameters. What are formal parameters? The formal parameters are the placeholders within the function's header that are used to receive the values passed into them. For example, in the following example, radius and pi in the function's header are formal parameters. So the comment is computing area. Now this function performs the task of computing the area of a circle. The name of the function is compute area. It's expected to return data of type double to the calling function or to the main function. Now this parameter called compute area has two parameters. These parameters are the parameter by the name radius and the parameter by the name pi. These parameters, if you check at them carefully, you can see that radius is of type double and the pi is of type double. My dear students and the rest of the learners, it's important for you to note that this is not like declaration of a normal variable. These are simply placeholders within the function to hold the value that has been received temporarily. Now, this function is performing the following activities. Number one, it contains the declaration of another variable called area, which is of type double or respect to whole data that is having decimal points. Now, this variable called area, which has been declared inside the function called compute area, is local. So this is a local variable. The next activity or the next task that this function is performing is to compute area. Now this statement simply tells the processor that it should pick the value or the content in the memory location called radius, which of course contains a value that has been received. In other words, radius here is the parameter called radius. So this statement is telling the processor to pick the value that has been received as a parameter through radius or through the parameter called radius, then multiply it to the value that has been received, through the parameter called radius. In other words, it is telling the processor, pick the value which has been received through parameter radius, multiply by itself, and then multiply the result with the value that is contained in the parameter that has been received, or the value that has been received through the parameter called pi. And the overall results, assign them or store them in the local variable called area. So by the end of this execution of this statement, we expect that in the local variable called area, there will be a certain figure. That is the figure that is sent back to the function that has invoked the execution of the function called compute area. So this statement here, the return statement, is simply telling the processor to return the results of the function called compute area, which of course are expected to be of type double, to the main function or to the function which contains the statement for calling this function that is called compute area. And that's all with that function. What about actual parameters? What are actual parameters? These are the arguments. They are the variables or expressions that are specified in a call statement to the function. They are associated with the corresponding form of parameters in the declaration of the variable. The order of arguments in a function call statement must match the same order in the function's handler parameter list. My dear students and the rest of the learners, it is important to note that if a function will contain the formal parameters, because these parameters are a part of a function's handler, then that same program must contain an actual parameter. I repeat, if a function is going to receive parameters, like in this case, it is receiving the function called compute area, is receiving two values. One value through the parameter called radius, and the other value through the parameter called double. Now, this program, which is making use of this function that contains the two parameter radius and the parameter pi, must also have what we call the actual parameters in the call statement. So the actual parameters are simply those values, the values that are sent, the values or variables that are sent to the function which contains the form of parameters through a call statement. So the order of arguments in a function call statement must match the same order in the function's handler parameter list. For example, radius in the following call statement for the function called compute area is an actual parameter, like this one here. So this is a formal parameter. Now let me make a correction here. This statement here I want to remove this part here. So that is our statement. So if you look carefully onto this statement here, which is area equals compute area, then you enclose radius and pi in parentheses, simply means that radius and the pi are the formal parameters. I have scrolled back so that you can have a look. Now, if you look at this header statement here, the name of the function is compute area. You can see it is supposed to receive two parameters in the following order, radius and pi. And therefore, when we go to our actual parameter in the code statement for the function called compute area, you can see that we are enclosing two values in this code statement. That is radius and pi. This means that the function called compute area is invoked and then sent two values which are stored in the variables called radius and pi, which then returns a result that is assigned to the local variable called area. In other words, my dear students and the rest of the learners, this statement simply means, or it is simply telling the processor to invoke the function, to take the control to the function called compute area and carry with it two values in the following order. The first value is supposed to be received by the first parameter, and that is the value for radius. Or the second value, which is the value of pi, is supposed to be received as a second value by the second parameter in that order. So when we go to the function called compute area, we expect it to have two parameters, one parameter being radius and the other parameter being pi with respective return types or with the respective data types. And the data types you expect is double, as you can see here. So radius will be double and pi is double. And that therefore means that if you are going to have this statement in your program, it means that the function which is going to invoke this other function called compute area must have radius and pi declared as local variables, and those local variables should be of type pi. Now, once the function is executed, the value or the result which is received is assigned into the local variable found in the function which is invoking compute area, and this variable is supposed to be of the type which is being returned. In C programming, all calls are by value. That is, passing is by value. This means that we just pass a copy of the values of the parameters in the function call into the parameters of the function itself. Therefore, even if the passed value is changed, the change does not affect the original value stored in memory. Therefore, if, for example, we have a function header for a function written as follows, the function name is compute area, is expected to return the value of type double, and it has two parameters, the first parameter being radius and the second parameter being pi, both of type double. The arguments called radius and pi are passed into it by value as indicated in its call statement, which is coded as follows. We have already discussed this call statement. So even if a variable is declared locally in one function and is also declared locally in another function with the same name, these are treated as two different and separate variables because one function does not see the local variables of the other function. The local variables can thus be those declared in the parameter list or those declared in a function's body. For example, in the following example, the variable called perimeter is a local variable in the function called compute perimeter. So the comment is computing perimeter, and the name of the function is compute perimeter, which is expected to return value of type double. As you can see, it is receiving two values. One value is received as parameter radius, and the second as parameter pi. Within the body of this function, we have declared one local variable on the perimeter, which is supposed to hold the value of type double. The next statement to be executed is the one which is requesting the processor pick the value that has been received through the parameter called radius, multiply it with the value that has been received through the parameter called pi, and the results multiplied by 2. Then assign the overall results to the local variable called perimeter. And therefore, because the variable called perimeter is a local variable, then we have to send back the results to the invoking function. And to pass these results, we pass the value that has been stored in the local variable called perimeter, and that's what the statement return perimeter and closed in parentheses do. The following is therefore a program in C that implements functions with the local variables and the parameter passing to request the user for radius, and then it computes and displays the area and perimeter of the circle. The comment is compute area and perimeter of a circle. So this program is expected to perform two activities or to perform two computations. One computation is to compute area, and the other computation is to compute the perimeter. The preprocessor directive is #include hestdio.h. Then this first function is for entering the value for radius. So it is supposed to invoke or request the user to key in a value for his or her circle of interest. The name of the function is radius and is expected to return value of type double. Then we declare a local variable called radius of type double. Then this statement is prompting the user to enter a radius for a circle. So this statement, enter a radius for a circle, will be displayed on the screen, and the cursor will be taken to the next line. And then this statement is reading the value which the user is going to key. The value which the user is going to key is going to be read, and then it is going to be stored in the memory location, in the memory address, by the name radius. So that value will be stored there, and the value entered is supposed to be of type double. That's what the identifier LF means. And then we return the value received as radius, or the value stored in the local variable called radius, to the invoking function as a radius. The next statement or the next comment is for computing area. So the next function is for computing area. Remember that adding comments in your code is key. It is important because it makes your program more readable to the user. The name of the function is compute area. It's expected to return data of type double, and it is receiving two values as parameters. The first value is radius, which is supposed to be of type double. The second one is pi, which is supposed to be of type double. In other words, the first value to be received will be stored or will be received as a parameter radius, and the other will be received as parameter pi. So the value, the first value to be received will be held temporarily in the placeholder called radius, and the second one will be received and stored temporarily or held temporarily in the parameter called pi. This function has a local variable. So we are declaring one local variable called area, which is supposed to be of type double. And then the next statement is telling the processor to pick the value received through the parameter radius, multiply it to the value received through the parameter called radius, and then multiply the results with the value that is stored in the memory location called pi. In other words, this statement is telling the processor to pick the value in the parameter called radius, multiply by itself, and then the result multiply with the value in the parameter called pi, and the overall results, assign them in the local variable called area. And then this statement is telling the processor to return the value or to send the value which is held in the memory location called area to the invoking function or to the main function that contains the call statement for compute area. The next function is for computing parameter. Its name is compute parameter. It's expected to return the value of type double. It's receiving two parameters. The first parameter, or the first value, will be received and stored temporarily in the parameter called radius, or the second one will be received and stored temporarily in the parameter called pi, which is of type double. Then we are declaring one local variable called the perimeter, which is supposed to hold data of type double. Then we tell the processor to pick the value that has been received through the parameter called radius, multiply it to the value that is held temporarily in the parameter called pi, and the results multiplied by 2, and then assign those results in the local variable called perimeter. And then this statement is telling the processor that this function should return the value or send the value that is held temporarily or that is held in the memory location called perimeter to the invoking function, which is the main. As you can see, this value, which is supposed to be sent to the invoking function of the main function, is of type double, and the return type for our function is also double. The next function is for computing area. Its name is compute area. It's supposed to return the value of type double, and then it has two parameters. The first parameter is to receive a value of type double, and that value will be held temporarily in radius. For the second one, the second value will be received temporarily as a second parameter. And that value is supposed to be of type double and is going to be held temporarily in the parameter called pi. Then we are declaring one local variable called area, which is supposed to hold data of type double. And then this statement is telling the processor, pick the value that has been received through the parameter called radius, multiply by itself, and then multiply what will be gotten with the content of the memory location called a pi. And then we assign the results in the memory location called area. And then we send back the content of the local variable called area as the function called computing area. The next one is for computing perimeter. Now, my dear students and the rest of the learners, as you can see, this is simply a repetition here for emphasis purposes. Computing area and computing perimeter. It's important to note the difference. And that's why here you can see we are computing the area and emphasis is on the local variable and the parameters. The difference, note the difference between the parameters and the local variable. Parameters are simply placeholders, temporary placeholders, but local variable is a memory location that has been set aside to be used to hold a value that will be used within the function called the compute area, and the same applies to the function called the compute perimeter. The next function is to output the area, to display the area. And the name of this function is called output area. Now, this function is not expected to return any value to the invoking function, and that's why it has no return type, and that's why we have the reserved word void. So void output area. It simply tells you, my dear students, and the rest of the learners, and tells the processor that this function is not expected to return any value to the caller, but it is receiving one value which is going to be received by the parameter or as a parameter for the area, and that value is supposed to be of type double. Then the first statement to be executed is this statement here, which will be displayed on the screen. So this statement simply means or says that display the following message on the screen. The area for this circle is pick the content in the main local or pick the content in the parameter called area, and then display it on the screen, but formatted to 6 characters long, with 2 of those characters being reserved for the decimal point function or section. And that's all with that function. The next function is for outputting area. Its name is output, not outputting area, but outputting perimeter. Its name is output perimeter. It's not expected to return any value to the caller. That's why it is of type void. But it is receiving one value, which is supposed to have a decimal point. And that value is going to be held temporarily in a placeholder called perimeter. And then this statement is simply telling the processor, display the following message on the screen. The perimeter for this circle is pick the content of the memory location or pick the content of the parameter called the perimeter, display it on the screen, but formatted into 5 characters long, with the 2 of those characters being reserved for the decimal point. And that's all with that function. From there, we go to the main function. The main function contains the following declarations. One is for a memory location which supposed to hold data that does not keep on changing. And the name of this memory location is pi, and the value being assigned into it or initialized, it is being initialized to 3.142. So the value there is not supposed to be changing. Then we have some local variables here. We are telling the processor to set the memory locations assigned called radius, area, and perimeter, which are expected to hold values of type double. Then we display the following statement on the screen. Program displays or demonstrates. Program demonstrates how to apply parameters. Then we now have what we call the functions statements. That is functions called statements. Now, when the processor encounters this statement, this is what it means. It is telling the processor, go and look for the function called read radius. Execute it. So once that statement or that part is invoked, the processor will come to this point. Look here. I want you to look at the order of statements. The first statement is this one for reading radius, invoking the function called read radius. The second one is invoking the function called compute area. The third one is invoking the function called compute perimeter. The fourth one is invoking the function called output area. And the other function is invoking the function called output perimeter. Now, this order of arrangement of 4 statements is key. You have to organize them in the order of use or importance. If the second function, like compute area, is going to make use of the value generated by the first function, like read radius, then the function for invoking read radius function should come first, followed by the invoking of the function which will make use of the value generated by the previous function. So once this statement is invoked, this part, read radius, it is telling the processor, go and perform the task performed by the function called read radius, and the value which will be generated be assigned in the memory location called radius. So the control will simply be taken to the function called read radius. So this is the part where the control will be brought. Then it will perform these activities here, return this value, and then control will be taken back to the main program here. And the value will be stored in the memory location called radius. Then control will be taken to the next statement, this one. It is telling the processor, go and perform the task or look for the function called compute area and carry with you two values. One value, the value stored in memory location called radius, and the second value, the one which is stored in the memory location called pi. So pick copies, carry copies of the content of memory location called radius and a copy for the content of the local of the memory location called the pi. Now those two, take them to the function called compute area. And after performing the task of compute area, bring the results and store them in the memory location called area. So when this statement is executed, what will be taken to that specific function, which is this one here, compute area. This is the function. Now, once this one is done, control will be taken back to the main function, where there is also be assigned the memory location called area. The same will apply this statement. Once it is invoked, control will be taken to the function called compute perimeter, and this control or this processor will carry with it two values. One value in the memory location called radius, and the other value in the memory location called pi. Take them to the function called compute perimeter as parameters. Perform the activities there, then bring the result back and assign that result to parameter or to perimeter. Then the next statement is this. Control be brought to this function or this call statement here. This call statement, it is invoking the function called output area. Now, as you can see, this function is not returning any value stored in any memory location, but it is carrying with it the value in the memory location called area. Once this statement is executed and this function is done with, the control will be taken to this other statement here, which is invoking the function called output perimeter, and it is carrying with it the value, a copy of the value in the memory location called perimeter. You can see it's also not going to bring any value, but the main function. Now, once this statement is executed, then this statement is send the control for the processor to take the control back to the operating system and automate the program. Let's now see how this program will behave by coding it in the Falcon IDE. So for us to do that, I expect you, my dear students, and the rest of the learners to copy this program. Just copy this program as it is and type it in Falcon IDE editor, or type it in a word processor, and then just copy it and paste it in Falcon IDE edit area or editor. So let's proceed with our program. So we are going to launch Falcon IDE. So you type here Falcon, or you can just click on Start, then go to Programs, and then look for Falcon IDE, then load it. Once it loads, click on File menu, point on New, and click on Project. Then under New Project, click on Empty Project, and click Next. And project name, give it a name. So I can call it, for example, I can call this one parameter passing. Parameter passing. Then compiler type is C. Then you click on Finish. You can then proceed and create a program that is C file program. Rename it so that it portrays what you want this file to do. So I'll call it, I'll give it the same name as the name of my project. So parameter passing. Then from there, once we are here, you can type your program on this section, or just copy it and paste it in your IDE if you have typed it in our processor as follows. So let's have our program here under the IDE and it. So here is our program. You can always remove what you don't want. That way. So we have our functions here. Now the first is, just as we have discussed, is the statement which is indicating what our function does or what our program does. That is, comment compute area and perimeter of a circle, compute area and perimeter of a circle. Then we have our preprocessing directive there. We have the definition of our first function here. That is read radius. The second one called compute area. The third one called compute perimeter. Then the fourth one called outputting the area. And the fifth one called outputting perimeter. Then we have our main function here. We have our body here. Now this body contains declarations of local variables that we have already discussed and the statements for invoking various functions. Now, as you can see, when you make use of functions, the amount of code within the main function becomes very little because most of the statements, most of the codes are taken back and invoked into the functions. And therefore, most of the instructions that you find in the main program or the main function are simply the call statements for various functions. Now, once you are done with decoding your program, you can save it. And as we said earlier, when you are saving a program for the first time, you are also saving the project. So once you save the project, you have saved all other files and or other programs related to. Or simply, when you click on save a file, because this file is contained in a project, what you just do, or what the program simply does, or the process simply does, is to save for you, or request you to save the project. Once you save the project, you'll also have saved the file. So you browse the location where you want your project to be stored and also your file, and then under file name, you type the name of your project, and then you click on save. It's always good to retain the name of your file to be similar to the name of your project, especially if that project contains just a single file or a single program. However, if you have several files, within the same project, those files can have different names. Now, once you have done that, you are done with decoding your program. You click on run, then you compile. As you can see, our compilation is successful. So compilation successful, meaning that our program does not have any errors. And therefore, we can proceed and run it or execute it by clicking on run, then run. As you can see, the processor is now prompting us to enter radius for a circle. Already, this tells you that the processor is executing the first function, which is read radius. The one which is supposed to prompt the user to enter radius of a circle. So you just key in a value like 5. And then you press enter. You can see immediately you have pressed enter after keying in the value for radius, the rest of the functions are executed. That's what you can see that the function for computing area has been executed. That is compute area. And as a result of that, also, the one for computing perimeter, that is compute perimeter, has been executed. And what we are seeing on the screen, my dear students, and the rest of the learners, are the values that are being displayed or generated through the functions called output area and output perimeter. As you can see in my code, that is compute area, that is output perimeter and output area. Output area and output perimeter. You can see it is telling us that the area for this circle is 78.55. The perimeter for this circle is at 1.42, and the process return is 0. So in other words, it means that the execution has been completed and the control has been taken back to the operating system. So once I press enter, we are taken back to our program. Let's run it again with a different value. Compute, that is enter radius for a circle. Let us enter a figure like 11. Then you press enter. You can see it has computed the area for this circle as 380.18. Then the next statement is the perimeter for this circle is 69.12. We press hit continue. Once you are done, click on File, click on Save All for your future reference, then close all. To close the files open and exit the IDE. And with that, my dear students and the rest of the learners, we have come to the end of part 18 of the series. You can now proceed to part 19 of 29, in which you are going to learn about what we call function prototyping. Congratulations for learning part 18 of 29 on variable scope, parameters and parameter passing in fundamentals of structured programming using C. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on EmilySwap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email emilyswap@gmail.com. Thank you very much for listening to me, and let's meet in part 19 of the series, and God bless.